Right, here we go. Question 5. So Harry draws a scale diagram of a portion of his garden that is covered in lawn. This diagram is shown below, and each box in the grid is 1 centimetre by 0.5 centimetres. Now you could measure those. Which one do you think's the 1 centimetre? Going across or going up or down? Which one looks bigger? Going across, yeah. So each of those lines going across is your 1 centimetre there. And the one going up or down is your 0.5. So you put your 1 across and your 0.5 up. Each centimetre in the grid represents 3 metres. So the width of each of these intervals is 3. So the width of them across is your 3 metres. It says use your trapezoidal rule to find the area of this. And there, once again, 1 centimetre is equal to 3 metres. So our trapezoidal rule, up like that, it's the width over 2. So what's my width? Well, the width, it's 1 centimetre, and 1 centimetre represents, let's say, 3 metres.
Total width across.
Well, it's not the total width of the cross, it's the width of each of the intervals. So if you look back at the picture there, you'll see it says h over 2. H over 2 is the width of one of the intervals. Here, Rebecca. What is this question there? So the width of each of those intervals is 3 over 2. Then if you're looking at the trapezoidal rule, it's the height of the what? There's y1. Y1 represents the height of the first. Good. So first plus the last plus the 2 times the rest added together. There's my first one there. So what's the height of the first? 0. Good. Plus the height of the last. What's the height of the last? 0. Plus 2 times the rest added together. Now you've got to find these rests added together. So there's one of them. So there's a wee bit of maths involved in this. So different ways you could say it. They're half a centimetre high, aren't they? So you could say, what is there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 halves is 5. 10 by a half is 5, which is 5 centimetres. And each centimetre represents 3 metres. So what's the height of that first bar? Well, that's 10. 5 times 3, which is 15. Do you get that? Alternatively, you could have said there, every 2 boxes was 1. There's 1, 2, 3, 4, 5. 5 full centimetres, and then 5 by 3 is 15. We're going for the second bar there. What different colour? So this yellow bar there. Once again, how many bars have I got? I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12 halves is how many? 6. 6 centimetres. And 1 centimetre is 3 metres. So your 6 centimetres is going to be 18. Good. I'll say there is a wee bit of thinking in that. Your next bar there. This orange one here. So you count them up. We've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10. 10 boxes. Each of them have a height of 0.5. Give you 5 centimetres. And then what are we going to times that by? 3. Good. So 5 by 3 giving you 15. Right, you do the same process. You just go on and do the remaining bars. See what you get. You just get 15, 12, 15. What was the next one you just got? 18. Let's see. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Yeah. 12 by a half is 6. 6 by 3 is 18. And this here, one here. 15. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 by a half is 5. 5 by 3 is 15. Good. Then you just have to work each of these bits out. So remember your trapezoidal rule. The width over 2, height of the first plus height of the last plus 2 times the rest added together. So you can keep it as 3 over 2. You can write it as 1.5. 0 plus 0 is 0. It's 2 times the rest of these added together. So inside your bracket, put in your calculator if you need. 15 and 18 is what? 33, 43, 40, it's 60, 75, 75 and 15, 19, 90, sorry, 19, 18, 108. 3 over 2 times 108, 216 times 1.5, 324, is it? Yeah. 324. Is that right? Yeah, perfect. It's good math. Say, for those that missed yesterday, the first 4 questions were recorded here yesterday. Tune in, it's a good watch. So definitely watch it. If you have an easy class today, just watch it both. Or just look up the solutions from the link that I put up there recently. So now I can walk at a speed of, this is tricky. You know, this is tricky. There's a wee bit of unit conversion in this. Now I can walk at a speed of 1.6 meters per second. So that means for every second, she's walking 1.6 meters. Right. So in 2 seconds, how much is she walking? That means in 1 second, 3.2, 1.6 meters. They've asked you for the speed in kilometers per hour. Now you could keep working off like that. You know, get the number of meters she walks in a minute, and then get the number of, meters that she walks in an hour, and then change it to 10,000. Alternatively, you can just think about this. There's 2 units we're changing. We're changing meters to kilometers and seconds to hours. So like, say if I was changing the length between kilometers and meters. 1 kilometer, I always do the kilometers, the bigger one first. 1 kilometer is how many meters? 1,000. So 2 kilometers is how many meters? So how do I change kilometers to meters? They give me the kilometers. So 1 kilometer is 1,000. 2 kilometers is 2,000. So how do I change kilometers to meters? Multiply by 1,000. Yeah. So 1 kilometer is 1,000 meters. 2 kilometers is 2,000. I'm going back the way. Instead of changing meters to kilometers, what do you think we do? Divide by 1,000. Just the opposite. And then the link between hours to seconds. Now, what are we going to go between? We don't go directly from hours to seconds. We go hours to minutes to seconds. Yeah. Hours to minutes to seconds. Now, start with the bigger one. I always think, 1 hour. Same, but 1 hour is how many minutes? 60. 2 hours, how many minutes? Yeah, so how do I change hours to minutes? Maybe 60, good. Minutes to seconds. 1 minute is how many seconds? 2 minutes is, so to change minutes to seconds, you times by 60. And then it's just the reverse. That'll be divided by 60. That'll be divided by 60. So what I'm doing in this, I'm going to change my meters to kilometers. Because another way that's written is 1.6 meters in 1 second per second, isn't it? So how do I change meters to kilometers? Yeah, meters to kilometers divided by 1,000. Yeah, so 1.6 by that by 1,000, And then how do I change seconds, which I am over here, say 1 second, to hours? How do I change seconds to hours? Divide by 60 and then divide by 60 again. By 60 and then divide by 60. Now you could just say, you could work that out by just keep building it up, 1.6 meters in 1 second. Just keep working out that way. Or this way, I would just throw it into my calculator and see what it spits out. You tell me, what happened to your calculator? Do I need a calculator? Yeah. Why am I dividing by? Because let's say it's 1.6 meters per second. So that means for every 1 second, you travel 1.6 meters. So I want to get it to kilometers per hour. So in order to go from seconds to hours, you have to go through minutes first of all. What? Well, divide by 60 and then divide by 60 again. So you have that there. And then that's the one. And what does that spit out at you? So I'll throw it in at once there. Huh? 5.76? 5.76? 5.76 kilometers per hour. That is tricky. There's a lot going on. I would spend my time writing this stuff out, taking the few minutes, and leave it to the end of the exam, and then have a look at it. This is 2019, as I say, it's a wee bit back. So the next one. Solve the following inequality where x is an element of R. And we're only going to use this x as an element of R when we're supposed graphing the number line. Remember what you use for R? When we are graphing it? What about the three possible letters in this?
The S and N.
Well, N, Z, and R. Now, N and Z, you would use dots because they're whole numbers. R, since they're real numbers, you use a ruled line. So solve the following inequality and show it on the number line below. What do you have there and what are you going to get rid of? What would you do? Brackets, good. So multiply out the brackets. So 2 times 3 is 6, minus 2x less than 8. Now when you're solving that, what way are you going to move it? You could move the 6 over. The only thing is, in terms of this inequality, there's an old silly rule you need to remember if you divide by a minus. I would just keep my x happy, keep them positive. So I would move it. So I would move my 2x over here and my 8 over there. So when I tidy that up, 6 minus 8, that's sine 2x. Otherwise, there's a rule about changing the direction of that sign. You just keep it the same. 6 minus 8 is minus 2, 2x. And then how do you work out what x is? Good, put it over. Minus 2 over 2. Now, when you're graphing that, you read from the x. Read from the letter. X is something to the minus 1. Larger, good, bigger. It's getting a bigger opening. X is bigger than minus 1. So we're going this direction. Happy enough? All them terms are bigger than minus 1. For R, we use a rule line. And then there's only one other thing that's going to affect us up. So X is bigger than minus 1. I use a rule line. Get a ruler for yourselves. And then the last thing you've got to decide, do you remember anything about that dot? Do I colour it in? Do I colour it in this? No, good. Because it's not included. You'd only colour it in if it was bigger than or equal to. If it's included, you colour it in. So that means all them numbers satisfy that inequality. Good. This one, I never actually spent much time doing. I'll show it to you now. Me, a good student will get this. You know, what you do here, like junior cert higher level would have looked at this. I would have said to them, you work downstairs before you go upstairs. What that means, get them to the same base. So I want to write each of those as 2 to the power of something. So I've got 2 to the power of 2x minus 1. Now 2 to the power of what gives me 64. So like if I have 2 to the power of 1. What's 2 to the power of 1 give you? 2, yeah. 2 to the power of 2, which means 2 by 2, which gives you 4. 2 to the power of 3, 8, yeah, it's just 4 times 2 as well. 2 to the power of 4, 16, yeah. 2 to the power of 5, 2 to the power of 6 is 64. There we go. So you have to write them as the same base. You could do trial and error, what value of x do I get until I get 64? So this gives me, well, I'll show you that after, 2 to the power of 6. This is what I mean now. Work downstairs. So I've got both of these in my 2's. That's my downstairs. And now I move upstairs. And what I've got upstairs is that. So 2x minus 1 is equal to 6. How do you work out what x is? Move the minus 1 over. So 2x equal to 6 plus 1. 2x equal to 7. What's x equal to? 7 over 2. Good. For 3.5. How did you check your answer? That is right now.
Did you put it back up?
Put it back up. You know, and that's what I mean. You could do trial and error in your calculator. You could go into your calculator now. Instead of saying 2x minus 1, you're going to go 2 to the power of 2 times 3.5 minus 1. Put that in your calculator and see do you get 64. So 2 to the power of, there's an x with a wee shaded in bit in your calculator. 2 to the power of 2 times 3.5 minus 1. And you get 64. You know, trial and error would mean I would try maybe put 1 in for my x, put 2 in for my x, put 3 in for my x. And my 3, my 4, 3 is too low, 4 is too high, go somewhere in between, split them. There's nothing wrong with that. Next one now, we're on the long questions. So I'll make it this paper done. 7 and 8 anyway. Here, Camogie, goalkeeper on a level pitch, hits a ball straight up into the air. The path of the ball travel can be modelled by that function. Now, these are lovely marks because you're getting to draw the graph. But just to test you, what shape is a minus 4t squared or a minus 4x squared? If I had a ball up into the pitch, what kind of shape is that? Goes up and then an n. Good. So a minus x squared is always an n. It's a plus x squared. It's a u. That's what we're going to generally be getting. Presuming there's a graph bit coming up. There is. Right. At what height was the ball when it was hit by the keeper? I got this question at the start. So when it was hit, the time's taken to be 0. So here where t is the time in seconds from when the ball is hit. So, and the initial time, you're subbing in 0. And ft was the height of the ball in meters above the pitch. The ball landed on the ground without being hit again. So how would I work out the height of the ball when it was hit by the keeper? I fill in 0 for my t up there to my rule. Remember, you either sub it in, if you get a chance, sub something in. Sub it in or let it equal. Minus 4 times 0 squared plus 16 times 0 plus 1. So the height there was 1 meter. You actually could have got it from this to your next bit. Right. Do you remember how to do these tables? What do you do in your calculator? How do you draw? Table. Your mode in 3, your menu in your 3. Off you go. And you'll know if you're right, if that value matches up. Put into your calculator your mode or your menu in 3. And you're typing in this thing. Instead of saying minus 4t squared, you want to say minus 4x squared. All you're doing is you're subbing in each of these points for my t up there. But your calculator does it much quicker. F of x, it's just f of t. So you're going to put minus 4 alpha in the right bracket, gives you your x, is it? Right, so minus 4 alpha in the right bracket, x squared, minus 16 alpha in the right bracket gives you your x plus 1. In terms of start at, some of your new calculators will say g of x, well, press equals, so skip through that. What are you starting at in this? 0, good. So your start, 0, your ending at 4, good. And what are you going up in? What's your steps? 0.5, good. No, I'm going to get used to call these out. So the first one, 1. What was your 0.5? Yes. 1 was 1.5. 2?
No.
Oh,
1:13.
1's 13 hours. I was thinking it should go up and then start going down. 13. 1.5 is 16. 2 is 16. We're going downhill now. The ball's coming down. 3 is 3.5. And 4. Perfect. Obviously, go then the next page, draw a graph. So you're just plotting them points. So like 0, 1, so on. 0.5 and 8. 1 and 13 and so on. Just plotting all those points. And then join them up in a nice smooth curve. That matches up to what we thought. Minus x squared or minus t squared. Giving you that issue. So the next one. Use your graph to estimate. You should show your work on the graph, so we need lines. The length of time the ball was in the air from the time it was hit. The time it was hit was at the very start. There's your start there. At t is equal to 0. So the initial time, if you ever see the initial sub in 0, up and down, sub in 0. The length of time the ball was in the air from the time it was hit until it landed on the ground. Now at the minute, has it landed on the ground? No. So how are we going to work out the time it took? How from the graph? So it still hasn't hit the ground here. What will I have to do with this? Like what height would it be when it hits the ground? 0. So I just have to continue that on down. You know, that's me showing the work on my graph. So what are we saying? When you continue it on down, 4.1, 4.2 seconds, like there's 4.5. What do you like in your graphs? 4.1, 4.2, yeah, whatever it is. I'll say 4.1. I'll go between them, 4.15. If you wanted to work out what time it actually hit the graph, what you could do back here, let it equal to 0. Do your minus b formula. Let it equal to 0. You'll get 1 to be a negative answer, probably over that side. Minus 0.1, say. And you'll get your positive answer over there. If you really were a stickler on it. And then your other one there, the length of time the ball was 10 meters or more above the ground. So how are we going to do that? The length of time. Give me a time when the ball was 10 metres above the ground. Or how would you find a time when the ball was 10 metres above the ground? What would you do? So pick out which axis measures the height, the X or the Y axis. Y. So there I can see my 10 metres. So how am I going to use my graph? I'm going to go straight across from the 10 metres to where it hits the curve. I just carried it on through. And now to get them 2 points, the length of time, I'll get these times when it was 10 metres. I'm going to go down. Say there and there. Fair enough with that? Now technically it says the length of time it was 10 metres above the ground. So 10 metres or more. Isn't it 10 metres or more above the ground? All of that. Through all that region there. So when did it start being 10 metres above the ground? After how many seconds? Roughly. Looking at your curve.
1.5 seconds.
Well, there's 0.5. 0.6, 0.7. Yeah, that's so 0.6 seconds, say, and started, and then it kept rising, and it's coming down. And when was the last time it was about 10 metres above the ground? There's 3.5 there, so 3.3 or so. Whatever your graph says. So technically it says the length of time. So how do you work out the length of time between those two then? Take it away. So what are we getting? 2.7 seconds. That's 10 metres or more above the ground. 2.7 seconds. Right. I think so far that's been a good question. You know, having doubts, them they love them ones to start where you're subbing on zero. Draw a graph, fill in your table, and then you're using your graph. Now they're like in differentiation here as well. We seen this yesterday. It's like question 3 or 4. Find f dash t. It does say the derivative of f of t. Now f dash t is the same as saying dy dx. We would have called it. Now how did we dip that? What was the process? Good. Excellent. Multiply down by the power, reduce the power by 1. So when I get f dash t or dy dx, I'm left with, so 2 times 4 is 8. When it's 8t, what happens your 16t? What does it become? 16, good. And what happens your 1? Gone. Number disappear. Excellent. So multiply down by the power, reduce the power by 1. Use your answer from d power 1. So even if I didn't know how to do this, make up something. Make up something, but we have to be able to diff. Paper 1's guaranteed. A question like this. Use your answer. So like if you practice all these, you'll be flying. Use your answer to d power 1 to find the speed of the ball when it had been in the air for 4 seconds. Have a guess. How am I going to use my answer for 4 seconds? What do you think I'm going to do? Sub it in. Good. Because I told us back this previous page, t was time. T is the time. So you're just going to sub in 4 for my t. You're either going to sub it in or you're going to let it equal. That's the only 2 options there. So minus 4 times 4 plus 16 minus 32 plus 16 minus 16. Check something here now. Height. It's in the speed. The minus just means that it's going downhill. You know what I mean? So still traveling 16 meters per second, but after 4 seconds, I was just checking, I was at 1 meter, so it was going probably its fastest nearly. It's just checking on your table. So it was nearly finished. So the minus just means it's going downhill and it's traveling 16 meters per second. Just before it hits the ground, so it's going to be going as fast. And then use your answer from d power 1 once again to find the value of t. And once we're saying to find the value of t, we're going to be leaving t in and letting it equal to the answer. Value of t for which the ball was descending. What does descending mean? Going downhill, good. We're on the end slope. and travelling at a speed of 3 meters per second. Now, I dare say it's before 4 seconds. 4 seconds, it was going down at 16 meters per second. It doesn't go as quick. Now, am I going to sub in my 8, or am I going to let it equal to 8 for this answer up here? Let it equal, good, because they're asking me to find the t. Find t. So that means minus 8t plus 6t is equal to 8. Now, technically, as I was saying, since it says descending, now, feck all, people would have got that. You'll have to put in your minus. I wouldn't be too worried if you didn't have your minus. Just because it's going downhill, you'd be penalised very little. And now to solve your equation, numbers one side, letters the other, I'm going to bring my 8t over, or my minus 8t over, just to keep it positive. Use the same rules that we did for the inequalities. So 16 plus 8 is equal to 8t. 24 is equal to 8t. T is equal to 24 over 8. T is equal to 3. Which kind of makes sense. 3 seconds, at 4 seconds it was going quicker, as we've seen up there. 3 seconds. Now you could have done trial and error once again. You could have kept subbing in values and you got your 8. And we'll make a starting question here. This is a wee bit of algebra. And then that's that paper nearly done. Tomorrow, is there anything on tomorrow? No, no practicals or.
I'll just say back to the start tomorrow.
They're on the day. Next week, perfect. So we'll get another paper out of the road tomorrow. So the power of an engine is measured in horsepower, using this formula, where R is the engine speed, and revs per minute, and T is the torque. Means nothing to me. But sometimes when you have them labelled, it makes things a bit easier. Find the power of the engine. So find the P that generates 480 units of torque. There's my T. 2,500 RPM. My R. Give your answer to the nearest whole number. What are you going to do in that? So, generally the first part is nice and easy. So you're filling it in to this formula, R times T over 5252. What am I filling in for my R? 2,500, good. My T is 80 over 5252. So you put that in your calculator, it does say to the nearest whole number. Can't be the nicest looking thing. You get 228.48. Yes. Yeah. 228.48. So that's where the nearest whole number is. 228. Next one. Rearrange the formula to get R in terms of P and T. Now this is where it gets a wee bit more accurate. This is your algebra. Now when it says write R in terms of P and T, that means we want at the end R is equal to something. So at the minute we have this. P is equal to R times T over 5252. How would you get rid of the fraction? Put it back over. Good. Bring it back over. You might say cross multiply. You know. So you've got 5252P is equal to R times T. Now we need to get R on its own. So how am I going to move that T? Is it simply a matter of coming across and changing the sign? It's actually not, because I'll show you this. R times T is RT, isn't it? 2 times X is 2X. Now, if I had for myself 2X is equal to 8, how do I get X on its own? Divide by 2, good. So when you're being multiplied, to get rid of it, you're going to divide. So how am I going to get R on its own here? Same as what I did over here. Divide by T, good. 52P over T. Now, it's important to fill in something for these, because without looking at the next question, that's where it is, I don't know. I bet you they'll ask you to work out R, but they give you P and T. So make up something here if you cannot get it. Make up something. You give it a go and don't be scared to make a mistake. Well, maybe it's not. But usually there'll be one then, find R. when they give you the P and the T. Oh, right, that'll do us there. 2 minutes.